Hello everyone. So let's start with a new session on multithreading. So in the previous class, we have gone into the basic details of multithreading. So we have learned about what a thread is, how to create a thread, right, and what are the basic differences between multiprocessing, multithreading, and so on. So in today's class, our agenda will be to go deeper and understand what thread synchronization is, right? What are the race conditions, how to resolve them, and what is a lock in terms of multi-threading. So thread synchronization may be defined as a method with the help of which we can be assured that two or more concurrent threads are not simultaneously accessing the program segment known as critical section, right? So on the other hand, as we know that critical section is a part of the program where the shared resources exist, right? So critical source contains the parts, right, where the resources are shared. Hence, we can say that synchronization is a process of making sure that two or more threads do not interface with each other or interfere with each other by accessing the resources at the same time. So we have to make sure that no two threads are interfering or fighting for the resource at the same time. So the diagram shows four threads trying to access a critical section of the program at the same time. To make it clearer, suppose two or more threads trying to add the object in the list at the same time. Now this act cannot lead to a successful end because either it will drop one or all objects, or it will completely corrupt the state of the list, right? So you cannot end in a successful state. So here the rule of synchronization is that only one thread at a time can access the list. So let's say you want to add elements. You cannot add elements concurrently. Rather, one thread at a time, you will go about adding elements or doing any function. So what are the issues in thread synchronization? So we might encounter issues when implementing concurrent programming or applying synchronizing primitives. So in this section, we will discuss two major issues, right? What are those two major issues? The two major issues are the deadlock and the race condition, right? So anytime you end up in doing thread synchronization, you will face two major issues. One is deadlock, and the other could be race condition. So in today's uh, class, we would be focusing more around race condition and how to resolve those. Okay, so shared memory and race condition. Let's get a brief overview about what the shared memory is and what is the race condition. So the process has some global state that can be shared among all threads, right? And each thread can also have its own local state, right? Now, since threads can share the same global variables, if global variables are accessed by multiple threads concurrently, then it's important to use locks, which are also known as mutex, to prevent race condition, right? The class threading dot lock is one of the way to implement locks. The global variables can be acquired and released by different threads, right? When a global variable is acquired by one thread, it is locked and cannot be accessed by another thread until the thread releases it. So different processes cannot share the same global variable, right? And each process actually makes a copy of a global variable if it tries to access it. But if processes need to share data with each other, you can use shared memory queues, right? The multiprocessing module provides a queue class that closely resembles Python queue class, which is a FIFO data structure. FIFO is first in, first out, right? So elements are popped out in the way they go. So it's like obtaining ticket in a movie theater, right? So different processes can put and get data using multiprocessing queue in the same way that a single process can put and get data using queue.q. And multiprocessing.q uses logs internally on the shared memory, right? So what it does, so users don't have to worry about race condition when using multiprocessing.q. So Python takes care of a lot of things for us. Let us deep dive into what race condition is. So before we move into some other features tucked away in Python threading, let's talk a bit more about the issues we will run into when writing threaded programs. So once you have seen what a race condition is and looked at at the one happening, you will move on to some of the primitives provided by the standard library to prevent the race condition from happening. Race conditions can occur when two or more threads access a shared piece of data or resource. So in this example, you are going to create a large race condition. It happens every time, you know. But be aware that most race conditions are not this obvious, right? Frequently, they only occur rarely, but they can produce confusing results. So as you might imagine, this makes them quite difficult to debug. Fortunately, this race condition will happen every time, and we will walk through it in detail to explain what is happening. So for this example, let's say you're going to write a class that updates a database. Okay, you're not really going to have a database, we're just going to fake it because that's not the point of this article. You're just going to write a simple fake database class that have its own constructor and have an update function, right? So let me restart the kernel. So if I restart the kernel and try to run this program, okay, logging is not defined. Let me import logging. Okay, so what happens here? So we start with the main function, we print something, we create a object of the fake database class known as database. Now what Python does is we are trying to create, a race condition. So with the help of executor, which is a part of the threadful executor, right? We are creating two threads, thread 0 and thread 1, right? And they both are starting to do the update. So they both call the update function, right? Now, okay, so what is happening? Database.value we are trying to update, but since the initial value is 0, we initialize with 0, and since there is a race condition, no one is able to update it because the threads do not know when to update, what to update. Because two threads are just fighting with each other to update. This is called the race condition. Now dealing with race condition using logs. So as we have seen the effect of race condition in our program, we need synchronization tool which can deal with the race condition, right, between multiple threads. So in Python, the module provides lock class to deal with the race condition. Further, the lock class provides different methods with the help of which we can handle the race condition between multiple threads. So the methods are described below. The acquire method. This method is used to acquire, that means block a lock. The lock can be blocking or non-blocking depending upon the true or false value. Now, if the value is set to be true, if the acquire method is invoked with true, this is the default argument, right? And the thread execution is blocked until the lock is unlocked. So it's like locking one of your doors and then unlocking it to use it again. When the value is set to false, the acquire method is invoked with false, which is not the default argument. Then the thread execution is not blocked until it is set to true again. And the release method, so this method is used to release a lock. So following are the important tasks related to releasing a lock. If lock is locked, then the release method won't unlock it. Its job is to allow exactly one thread to process. If more than one threads are blocking and waiting for the lock to become unlocked. So the major idea here is that we want a single process to run at a time, right? Because Python's GIL supports only single process to run at a time, single thread to run at a time. So it will raise a thread error if the log is already unlocked. Okay. If we look at this program, we restart it. If we look at this program, what is happening? Start with the main function. We create a lock object. We create two threads, T1 and T2. Pass the argument lock and pass the target function to work upon. Simply write T1 dot start, T2 dot start. This starts both the thread, right? Now when both the threads are started, what it will do is it will go and run this loop half a million times and will try to increase the value by one, right? So what is happening is for we are trying to run this 5 times. So the following output shows as the effect of the race condition is neglected as the value of x after each and every iteration is now 1 lakh, which is as per the expectation of the program. Since we are using lock, so each thread is working one at a time, and once a thread has completed its task, then it moves to the second thread, right? So this is how lock works to help deal with the race condition. Understanding the semaphore, right? So maybe we'll try to learn semaphores and deadlocks in the next class. Till then, you should try to sort of go ahead and write simple programs. Try to understand what lock is. Try to understand how to deal with the race condition and what are the two important methods, acquire and release, right? So we have learned to use lock, but in the later classes, we will also learn to use acquire and release. So I think I hope you have all enjoyed the class, and thank you everyone for watching the video. Have a nice day. Bye.